Ooh, okay. That was almost bad. For some reason, OBS didn't want to connect to the stream. It was saying that the broadcast didn't exist, but I think we're good now. Just confirming that the stream eventually starts on my other monitor, but I think it's good. Anyways, oh, there it goes. Perfect. We are live. Welcome back to Advent of Code 2022. This is day 3. Unlike with yesterday, I actually remembered to update the bottom banner. Now it says day 3, as it should have been updated to day 2 yesterday. Still feeling good about today. Shouldn't be anything that out of the ordinary. I went back and looked at this distribution of time it took to solve, you know, every problem every year, and day 3 actually was pretty long. I think it was either in 2017 or 18, but that's because the problem was this spiral matrix thing. Oh, hello. I probably won't be reading too much of chat until after I solve, but feel free to chat and ask questions afterwards. I'll do my best to answer while I walk through the problems. Groups of 3. Okay. The only item that appears players and all 3 rucksacks are... Okay. Cool. Not bad for today. Just gonna give it a little bit of time to let the leaderboard settle, but pretty happy. Beta Barrel's moving up into position 1, as expected. But we didn't do too bad today. 48th on part 1. Moving into, 49th on part 2. Oh, wow, close. We squeezed in behind all these 42nd people. Oh! I beat Jonathan Paulson by a second. Probably one of the top players who actually streams regularly as well, so that's really cool. Leaderboard should be locked by now. Yep. Cool. Well, yeah, let's walk through today's problem. I did not narrate any of my thoughts, so... And I realized it probably isn't really that helpful to... I think it's more helpful to kind of code everything from scratch when I'm going through the problems. So I'm gonna try to do that this time while I talk through the problems. And if you're in the chat, feel free to ask questions and stuff too. So, this question had a lot of flavor text about elves. It talked a lot about, well, it tried to highlight compartments, which took me a while to realize. And in part 1, you're given these lists of things that different elves, or different rucksacks, I guess. And these rucksacks have 2 compartments. So in this list, the first half of it, so for example in this one, up to the R, is considered the first compartment. And the latter half is considered the second compartment. And the question asked, and I guess important to note, there's a mixture of uppercase and lowercase characters, and those are treated as different item types. So basically each unique character here is an item type. And basically what the question asks is, I didn't actually read the question fully while I was solving it, so I'm gonna reread it again right now. Given when I saw this and the fact that I was looking for the common elements between the 2 halves, can I zoom a bit? I could probably zoom this, and now I guess I can zoom my editor too. Okay, that's probably too zoom for the problem. But yeah, I can zoom the editor because we don't really have to do too much stuff. Hopefully that's visible now. Let me know if you want it zoomed a little bit more. I have a weird setup because my display is like an ultra wide, so we lose out on screen space too because I have to have this like big banner at the bottom. But hopefully this is visible with enough quality now. And so For part 1, it was basically saying, okay, so you can split this rucksack into 2 compartments and then ask what the common item is between the two. So in this case, if you look at this and look at this, the only common thing between them is this lowercase p. And you can do the same for each of these. When I was solving the problem, I didn't read that. I assumed that there could be multiple things that were common between them. So I coded something accordingly that would work with that. So let's just figure out how to code part 1, right? So part 1 asks us to go through every line in this. Oh, great, that is readable. So every line is like its own unique problem. So we're gonna need to keep a running count of like our score so far, and then we'll say for line and day. Ignore the fact that this doesn't make any sense. Just pretend that I'm iterating through every line in this file. I have some magic going on that reads the input, but depending on whatever language you're using, or if you're just doing a basic thing in Python, something I like to do is, if you're piping standard input to your file or something, you can use file input and then do like for line and file input.input. That'll work, it'll be almost identical, but this is just a nice way for me while I'm on Windows to read in inputs, either from the problem input, which is here, or from what's on my clipboard, which I like to do for testing. So the first step is we need to split this line into 2. Does it say here, oh, a given rucksack always has the same number of items in each of its 2 compartments. That's a fancy way of saying there's always an even number of characters in the string, so there's always a obvious way to cut it in half. You don't have to worry about, if it's odd, which side does it go onto. So the way I decided to just do this was saying, I guess, the first half the first compartment is going to be, well, first we'll define the length of the line, and the first half is going to be everything in the line up until the like halfway mark of the array, right? Or of the string. So we can do that as n divided by 2. And then the second half is going to be the rest of that. So we take everything from the half of the string onwards. It occurs to me now that I should probably have a utility method to kind of chop a string into 2 parts like this. I think that would be a useful thing to have. So that's something we learned from today's problem. Okay, now the next thing to do is compare the 2 compartments and figure out which things are common between them. The way that I decided to do that, because I wasn't sure that there was only ever a single element that was shared, is turning these into sets and doing a set intersection. So let's hop into the editor this for a second. If you have a set of like many things, sets always contain unique. So if you do something like this in Python, right? This set contains the numbers 1, 2, 3. This set contains the numbers 3, 4, 5 because duplicate values don't matter. In Python, you can do some. So they're similar to the mathematical concept of a set, and so you can do things like unioning 2 sets, which basically adds them together. It's which elements are in A or in B, or what I took advantage of is the intersection of 2 sets, which elements are in A and B. So for example here, the number 3 is only in, out of all these numbers, 1, 2, 3, 4, 5, 3 is the only thing in A and also in B. So A and B returns 3. So I took like basically this half, turned it into a set, this half, turned it into a set, and then just asked what's the intersection of that set. I suppose you could have done it another way too. You could have just done it this way probably, where you say like for x in the first string and then for y in the second string, if x is equal to y, then it means that it's common between the 2 things. In retrospect, this probably actually would have been faster to code. I don't want to get too much into a little tirade about time complexity or anything, but because these strings are so short, honestly, this probably performs just as well or even better than doing a set intersection, because you don't actually have to hash the strings and do like hash comparisons. So maybe we'll just code it this way for fun at the end. So we want to look at things that were in here and things that were in here, and if they're the same, because we were guaranteed that there's only ever one thing, it's a common element. And so now we get to the second part of the problem text here, where it basically maps like what's the point value of everything. Like if A was the common thing, like what is A worth? And so it's saying lowercase a is worth 1, all the way to lowercase z is worth 26, and then uppercase is here, 27 to 52. This was a clever thing that Eric did, I guess, to make the problem a little bit more difficult, because I'll hop back to the interpreter here. As you might know, ASCII values can be mapped to numbers, and the way you can do that in Python is by saying ord. So the ASCII value of capital A is 65. And the ASCII value of lowercase a is 97. So why I say it's a little clever is because if Eric had swapped these and said A is worth 1, or the capitals are the, I guess, cheaper things, and the lower cases were the more expensive things, then all you would have had to do is said like, what is, for example, let's say our character is, I don't know, D, right? All you would have had to do is say like ord of the character minus the first ASCII value, and it would have given you the value, or +1, I guess we're classic off by 1 error, right? Because then if, for example, C was one of like Z, right, the biggest possible value, you get 58. Is that right? Why am I getting 58 here? Oh, okay, I guess it doesn't work because there's characters in between. Oh, because it has to map to 32. Okay, ignore that. I forgot how my ASCII tables work, so we do have to do this anyways. Basically, the check that I did here was, so if we get to this point, they're common. And so if, I want to know if it's uppercase or lowercase. And so the way I just did that was basically asking if, arbitrarily we could just pick one of them. So if x.lower is equal to x, that's going to be true if x is lowercase, right? So then we have to figure out, well, how many points is that worth? Oh, I'm missing this here. And we can compute that by basically taking what I demonstrated before, right? We take the ASCII value of what x is and subtract off the ASCII value of the lowercase a. So if x was a lowercase a and we subtract the ASCII value of lowercase a, we'll get 0, but we want it to be worth 1 point, so then we add 1 back later. Otherwise, you know, it's kind of the same sort of thing, but we're dealing with uppercase characters. And so if we do that, this should give us the result for part 1, unless I'm very mistaken. Oh, I'm not calling it total anymore, I'm calling it part 1. Like so. And now let's test it out. So here's our sample input, and we can run it with this. Oh. So, is this not working because I'm double counting, probably, with this new version? Or I'm just totally wrong? Let's do some debugging, shall we? Let's print out the common letters that we found for each of these. This is very strange. It's printing the P, and then here's printing L many times. Oh, I guess we did have to do the set thing in the first place. Where in the text does it say that? So this is interesting. I guess I made an assumption about the problem, but there's like a lot of L's in the second compartment here, for example. But all that we care about is that the type of item that appears multiple times is the uppercase L. So actually, doing this kind of naive loop doesn't work because it doesn't make sure that we're not like multi-counting an object. I guess what we actually could do though is break out of the loop once we find something that's common for the first time, and also if we... No, I feel like that's an unclear way to do things. I don't want to introduce that sort of confusion for the control flow. So I'm going to go back to doing it the way that I did originally. So the common elements are going to be the set intersection of the first compartment and the set intersection of the second compartment. So let's just do something like that. And then I think there's better ways to do this in Vim. For every common letter C in common, even though we know from the input that there's only going to be one. If C equals C dot lower, we want to do this, and this variable is called C now. Otherwise we do this. Let's see if this works. Okay, our math is wrong now, but let's make sure that the element types are right. Yep. So why are we off by the point values? That's the interesting question here. Let's print what? Oops. It's funny how I'm writing bugs when trying to go through it. The uppercase things are worth more, right? So this is actually worth 27 if it's a capital A, 28 if it's a capital B, and so on and so forth. So yeah, now we get the 157 that we expected to get here, and if you run it on my full input, you get 80, 85, which is, you know, what we expected here. I'm going to remove this excessive printing. So for part 2, instead of each of these representing a single rucksack, I guess it still does, but we want to basically compare what things are common across all 3 in a group. So in this example, the first 3 form a group of rucksacks, the second 3 form another group of rucksacks, and so on and so forth. And so, again, I'm realizing I probably should have had some sort of helper to say split this list into groups of n. You know, I probably actually have that. I'm curious. Maybe we don't have it. Okay, we'll write that later. So it's a very similar problem, right? Here we had basically comparing what's common between 2 groups of things. But in this part, it's going to be 3 groups of things. It's a little complicated because we have to like read in 3 groups and then do a computation. Read in 3 and then do a computation. And so the way I did it when I was solving it, and I think there's probably better ways if you write a helper to kind of group these into groups of 3. Maybe let's do it that. Let's be a bit nicer than this, actually. So let's think of a way to group these into groups of 3. And one way to do it is by using zip, I guess. So I'm gonna delete this for now and do something like this. So for A, B, C and then I'm gonna zip together a few iterators. I'm going to zip together line, and I'm gonna start at 0, go to the end, and skip by 3. I want to start at the first thing and skip by 3, and I'm gonna start at the second thing and skip by 3. And I'm just going to print this out to see what we get. That's not what I was expecting to get. Oh, I meant day. We're iterating through all the things in the day again, not line. So instead of, so with the slicing notation, which is kind of looking like an array index, you can provide the start and the end of a list, and that's kind of what we're doing here, right? For here we're doing this as the start, here we're doing this as the end. But it actually takes a third argument too, which is how far, how many things to skip. So basically what day 0 skip by 3 is returning is this thing and then this thing. Here we're saying start at the first element, or the second element, index 1, and skip by 3. So this iterator is going to return this and this. And likewise, this thing is going to start at index 2 and skip every 3. So it'll return this one and this one. And what zip does is it basically like links all of those things together. So a good example of zip here, if I go back here, if I have two lists, 1, 2, 3, 4, another list, I don't know, 5, 6, 7, 8, and I zip them together, and whoops, and I convert it, sorry, my terminal isn't set up correctly, and zip them back together, we get this, right? We'll kind of imagine a zipper, and you're kind of squeezing the elements together. So 1 and 5 are here, 2 and 6 are here, etc., etc. And so we can unpack that object back here into an A, B, and C, and now we have essentially first and second from here. And so we can do the same thing, right? We can say, well, what's common between what the first elf is holding, the second elf is holding, and what the third elf is holding? And then this is all exactly the same here, except we want to do part 2. Because the scoring rules are the same. So, and just for the sake of completion, let's just visualize what this is. So, this is what the elves are holding, and then we'll ask what is common between them. So, for group 1, this is what the first elf, second elf, and third elf are holding, and the common letter is an R, right here. And in this example here, you know, these are what those elves are holding, which correspond to these lines, and the only common thing between all of them is the capital Z. And in the sample input, we would get 70 as the example here, and if I remove the print statement and I run it on my actual input, we get 2515, which was the answer. Okay, so recapping solving this problem, it actually probably was a good thing that I solved it with doing the set intersection instead of just the for loop and comparing when I found a common element, because I had no idea that you could have a repeated element in the compartment. I wonder where in the problem stated that. It was probably implied here. Yeah, exactly. The amps. So Bob Jr. in the chat. Yeah, if you go to, so I'll just like make these sets again. If you have A is this set, right, and B is this set. So I was using A and then the binary and to do this. It's the exact same thing as calling intersection of B. They're basically shortcuts for one another. Just like if you want a union like this, the underlying method that actually gets called is union. It's the same thing. So just a convenient thing. One is quicker to type, I guess, but if you have your, I guess, discrete math and you remember like the concepts of union and intersection, but don't necessarily remember the bitwise operators, you could type it that way too. But yeah, getting back to the original thing I was thinking about, I guess it's implicit that it asks about the common item types, meaning L is the type of the item, but there could be many L's actually in the compartment. But anyways, yeah, pretty happy with how today went. Hopefully it was an informative stream. If all goes well, I should be streaming again tomorrow. Feel free to hop in the chat, ask questions. I'm on Twitter and stuff, I guess. Leave comments if you have more questions. But thank you.